Hello, thank you for your time today. I'm Brian Hageman, inventor of the hydraulic engine, and I'm showing how I'm going to put my technology to use in Arizona at the new Palo Verde Desalting and Hydrogen Production Facility. This presentation was prepared for the Arizona Corporation Commission commissioners and the Resource Planning Group at the Arizona Corporation Commission. We need to provide a diverse water supply in Arizona, and we need to use renewable energy for a sustainable future. And I'm going to show you how my technology is going to do that. We have a huge source of water underground. It's called the Buckeye Waterlogged area. It's been documented a few times by the Arizona Department of Water Resources. And it's a massive underground aquifer, and they call it waterlogged because there's a bottleneck in the water flow on the southwest end that traps the underground water and makes the water table very shallow. There's places you can dig about 4 feet and hit the water table. Unfortunately, guys, this water is too salty to use for human consumption, farming, or ranching. It's called brackish water. It's got about 3,000 parts per million of salt, and the most we can drink, healthy wise, is about 500 parts per million. Most of our water in the Phoenix area is lower than that, around 200 to 300 parts per million. But what we need to know is how much water is in this waterlogged area, and I'm going to talk about my analysis of that waterlogged table today. According to the Arizona Department of Water Resources, all the water underground flows from east to west and north to south. That's coming down the Salt River from east to west. Underground, there's the underground water flow, or from north to south along the Agua Fria River or the Hacienda River from north to south. All the water flows into the bottlenecked Buckeye waterlogged area. One thing underground that's unusual that happens is at Luke Air Force Base, there's what's called the Luke Salt Dome. And all the water, it's this gigantic salt formation underground that's been there for a million years, that all the water from north to south here flows over and around the Luke Salt Dome. So everything below that is salty water that contaminates the water. And unfortunately, now we can't use that water for human consumption, ranching, or farming. Um, the water then, after the bottleneck, flows down to the Gila Bend area and then flows all the way down to Yuma and south to the Gulf of California, Sea of Cortez, where it gets contaminated completely with ocean water. All this water that's given to us by nature should be used in a sustainable world. We should be using all this good water before it ends up in the Gulf of California. But again, it's too salty. A lot of geologists argue about why is there so much salt in the water here? I think it's because of the Luke Salt Dome, but a lot of the geologists in Arizona believe it's from farming operations that end up with the sediments, salt sediments from farming operations that ends up in the underground water. In my recommendation report to the governor, I explained and tried to quantify how much water is in the aquifer underground. This bottlenecked waterlogged area is huge. There's a massive amount of water underneath all the farmland in Buckeye. And like I said, it's so shallow that it actually is disturbing the crops. And the salt water, when it hits the root lines of crops in Buckeye, it tends to kill the crops. So what we do is pump water out of that area and lower the water table for the benefit of the farmers. My new Palo Verde facility will be right at the end of that farmland. And what I'm showing is that with desalting this water that's too salty to use, taking the salt out of that water with my facility, is going to give us an assured water supply for over 50,000 homes that's ready for desalting right now from the water that's being pumped out of the Buckeye Valley area. This desalinated water could feed enough water to 50,000 homes that could serve the North Buckeye area, an area that will be developed and about the size of Scottsdale, Arizona. We've been lowering the water table through the use of 9 well pumps in Buckeye that's been pumping water 24 hours a day, 7 days a week, out of the water table to lower that water table for the benefit of the farmers, so it doesn't affect their crops where they grow their alfalfa. And to give you an idea of how much water is being pumped, I did a study of all the 9 wells. Turns out to be 8.3 billion gallons per year that's being pumped out of the ground. And if all that water was desalted before they pump it and it drains back into the Gila River and goes back underground, but that whole 8.3 billion gallons per year, like I said, it's enough for 50,000 homes if desalted. And to give you an idea about what 8.3 billion gallons of water is, that would fill the 42-story Bank One Tower in downtown Phoenix twice a week. If you turn the Bank One Tower into a big aquarium and emptied it twice a week, we'd be able to fill it up with water twice a week. That's a huge amount of water that's being lost. It's being lost. We're not using it, and we should be using it. We just have to take the salt out of it. My new Palo Verde Desalting and Hydrogen Production Facility is located in this aerial view. This gold square right here is my property in Palo Verde, 12 acres that'll house the facilities for my first desalting facility. I plan to build 5 or 6 more desalting facilities through the Buckeye Valley to take advantage of the water resource that we have there that's not being used. And also the hydrogen production facility will be on this site, and it'll be the first of dozens of hydrogen production facilities that I'm going to build throughout Arizona. This facility, when fully built, will produce 1.5 billion gallons of water per year and 95,000 MCF of hydrogen per year. That MCF is thousands of cubic feet, so that's actually 95 million cubic feet of hydrogen per year that I'm going to be producing from this site. That's enough fuel for a whole lot of industry and hydrogen powered cars. We'll also be producing hospital grade oxygen and rock salt from this facility. Each one of my phase 3 projects consists of the 24 solar collectors. These are dish type concentrating solar collectors that collect the heat from the sun. Collects the heat up 1,000 to 1,200 Fahrenheit, and then I pump it into a storage area, a thermal storage battery that we store the heat in a kind of a man-made geothermal underground storage area, and then that heat provides my engines 24-hour fuel, so I can operate my systems 24 hours a day and desalinate water, make electricity, and also produce hydrogen. Each one of these phase 3 projects will be built one at a time. There'll be 4 of them in the full design that'll be built through the 12-acre property. We'll have a lagoon. This is the raw water that I'll be pumping out of the underground aquifer, all the salt water in a lagoon that'll supply my desalination systems. And then the byproduct coming out of desalination with reverse osmosis is the salt, the heavy brine that comes out. But I'm going to send that through some more solar collectors that will evaporate and condense even more water out of that water stream, leaving a salt mud that'll dry out into salt rock in this area of the facility. This phase 1 and phase 2 project down at the south end of the facility will be built first. The phase 1 and phase 2 will produce 150,000 gallons per day of desalted water and also a good supply of hydrogen. And we need to get this first facility up and running with customers, and then I'll be able to qualify for water bonds from the Arizona Water Infrastructure Bond Authority. Will be able to provide bonds for the phase 3 projects. The hydrogen production facility that we'll have on site uses electrolysis. Electrolysis is a way to take the oxygen and hydrogen atoms that are connected together with a magnetic bond. If you feed electricity, DC electricity, into the cathode and anode with a membrane, electrolyte membrane in between, the atoms will break down their magnetic field and become oxygen and hydrogen gas. It's a fairly simple process. This will be our own in-house design of these vessels and cathodes and anodes that will break down the hydrogen. And since our generators produce DC electricity, we've already got the DC electricity we need from our generators that are 100% solar powered. This is going to produce hydrogen at a much lower cost. Being made with 100% renewable energy, I'll be able to produce hydrogen gas at a cost lower than natural gas. This is our future fuel for industry and transportation that produces zero emissions when burned. The Palo Verde Desalting and Hydrogen Production Facility will provide our state with the diversified water supply that we really need. We've got good water supplies from surface water, groundwater, Colorado River, but we need more. And there's this massive water supply that we're losing. Every day the water flows and we lose it to the Gulf of California. We need to use it. Nature provided it to us, and for a sustainable future, we need to be using as much of that water as we possibly can. But you have to do it with 100% clean renewable power to be the sustainable future that we all want. My system for desalination uses reverse osmosis and evaporative desalination to squeeze out every bit of that clean water out of that salt water that we possibly can. The electrolysis hydrogen generation is a proven technology that can be built fairly cheaply, and we can produce the gas at a lower price because the compression that has to be done, we don't need electricity off the grid to do that. We supply the electricity ourselves. This all comes to us because of my technology, the hydraulic engine, that is the most sustainable power system you can find. And everything we do is going to be at competitive prices to our customers. Thank you very much for your time. If you'd like to contact me, you can get me email-wise through info@brianhageman.us, or go to my website and check out other videos that talk more about this Buckeye waterlogged area at www.brianhageman.us. Thank you very much.